Hi guys, here's your video going over the Chapter 6 test review, which covers vectors as well as complex numbers in trig form. So the first thing we want to do is find the magnitude of the vector in the smallest positive angle, that should say from the positive x-axis to vector A. So magnitude is just like the Pythagorean theorem. So magnitude of A is going to be the square root of 0 squared plus 10 squared. That gives me the square root of 100, which is 10. So magnitude is 10. And in order to find the smallest positive angle, I need to actually graph this vector. So this vector is similar to the ordered pair 0, 10. So 0, 10 would put you somewhere up here on your positive y-axis. And the angle is going from your positive x-axis to your y-axis. And that angle is 90 degrees. So theta equals 90 degrees, or in radians, pi over 2. For number 2, again, going to find the magnitude. So just doing the same thing, Pythagorean theorem, so the square root of 10 squared plus negative 10 squared. That gives you the square root of 200. Let's erase that. And that simplifies to 10 root 2, because 200 is 100 times 2, and we know the square root of 100 is 10. And we don't know the square root of 2, so that just stays in the radical. And then to find my angle, I'm going to go ahead and graph this. So it's like graphing the point 10, negative 10. That puts me over here in my fourth quadrant, where this side is 10 and this side is negative 10. So I'm going to use the inverse tangent since I have my opposite and my adjacent. So inverse tangent of negative 10 over 10. I'm going to grab my calculator, make sure my calculator is in degree mode. Sure is. So inverse tangent of negative 10 over 10, or negative 1, gives me negative 45 degrees. Now we always want our angle from our positive x-axis until we hit our vector, and we know this angle is 45 degrees, so that means my angle in standard position is going to be 360 minus 45, which is 315 degrees. And that in radians, if we had to have that in radians, I would take 315 divided by 180. That gives me 7 pi over 4. All right. Number 3, magnitudes and directions of two forces acting at a point P are given. Approximate the magnitude and direction of the resultant vector to the nearest whole number. So what we want to do first is we want to find the components. So I'm going to call this force number 1 and force number 2. So for force number 1, I'm going to find my vertical and my horizontal components by taking the magnitude, which is 70, and then my horizontal component is going to be times cosine of 320 degrees, and my vertical component is going to be 70 times sine of 320 degrees. And I am going to do the same thing with force number 2. So for force number 2, my magnitude is 40 and my angle is 30. So I have cosine for x and sine for y, or cosine for my horizontal component, sine for my vertical component. Now the resultant vector comes from adding these two vectors together. So what I want to do is I want to add the corresponding components together. So I'm going to add these two together and these two together. And I'm going to do that all in my calculator, and this is going to be the resultant vector. So typing in my calculator, I have 70 cosine of 320 plus 40 cosine of 30. And that gives me 88.26. And then I'm going to do the same thing for my vertical components. So 70 sine of 320 plus 40 sine of 30 gives me negative 24.995. Okay, now it does say to round to the nearest whole number, but I'm going to do that at the very end since I'm still working through the problem. So I need to find the direction and the magnitude. So the magnitude of r comes from using the Pythagorean theorem. So I'm going to take my horizontal squared plus my vertical squared. And then I'm going to take the square root. So 88.26 squared plus negative 24.995 squared. And that gives me 91.73, but it does say to the nearest whole number, so we'll say this is 92. And it has the same units as the original magnitude, so this will be 92 pounds. And then for my direction I always need to graph my vector. So my horizontal is positive, vertical is negative. That puts me in this fourth quadrant over here, where this is 88.26 and this side is negative 24.995. And once again, I'm going to use inverse tangent since I have my opposite over my adjacent. So it's always my vertical piece, so 24.995, over my horizontal component. And of course, that's going to give us our reference angle, not the actual angle in standard position. So I have negative inverse tangent of negative 24.995 divided by 88.26 gives me negative 15.8 degrees. So in standard position, going from my positive x-axis until I hit my vector, I'm going to take 360 minus 15.8. And that gives me 344 degrees. So my direction is 344 degrees. All right, number 4. Approximate the horizontal and vertical components of the vector that represents a child pulling a sled through the snow by exerting a force of 20 pounds with an angle of 40 degrees with the horizontal. So you've got this kid pulling a wagon. There's my wagon. Here's my kid with the longest neck ever. There we go. He is exerting a force of 20 pounds. So this is 20 pounds and the angle is 40 degrees. So this just asks for the vertical and the horizontal components. So for my horizontal component, I am going to take my magnitude, which is 20 pounds, times cosine of 40. And for my vertical component, I am going to take my magnitude times sine of 40. And using my beautiful piece of technology that is the TI-84, I have 20 cosine of 40 gives me, it says to the nearest hundredth, so that's 2 decimal places, 15.32 pounds. And for my vertical component, I have 12.86 pounds. So this question was just asking for the components, which we have. All right, number 5, find the dot product and the angle in between them to the nearest tenth. So the dot product, I'm going to write these vectors in the vector form instead of the ij form. So if I look at number 5, I have the 9i, but I don't have a j. So that as a vector would be 9, 0. And my other vector is going to be 5, 4. And to find the dot product, what I'm going to do is I'm going to multiply my corresponding components together. So 9 times 5 plus 0 times 4. And the dot product ends up being 45. And then for the angle in between, there is a formula. So for the angle in between, you need to know three things. You need to know the dot product and the two magnitudes. So I'm going to go ahead and find, I'm going to call this vector A, and this is vector B. So my magnitude of A is going to be the square root of 9 squared plus 0 squared, which is 9. And my magnitude of B is going to be the square root of 5 squared plus 4 squared, which is the square root of 25 plus 16, which is 41. And then now I'm going to use the formula to find the angle in between, and that formula is cosine of theta equals the dot product divided by the two magnitudes. So now I'm going to plug that in. My dot product was 45. My two magnitudes were 9 and the square root of 41, and that of course equals cosine of theta. And in order to actually solve for theta, I need to use the inverse because I'm solving for an angle. And I'm going to type this all into my calculator at once. So inverse cosine of 45 divided by 9 square root of 41. Now I would highly recommend using that fraction bar on the calculator like we've talked about in class, and that's going to be alpha y equals. That way your calculator doesn't give you the wrong answer. And this says to the nearest tenth, so to the nearest tenth is 38.7 degrees. All right, number 6. So 6 has the j but doesn't have an I, so I always comes first, so that's 0, 6. And then this one has the I but no j, so negative 4, 0. I'm going to find the dot product again. So I have 0 times negative 4 plus 6 times 0, which gives me 0. And then to find the angle in between, you can do a couple things. You can go through this entire process like we did for the first one, or you can recognize that your dot product is 0. Anytime I have two vectors and the dot product is 0, that means they are orthogonal, and orthogonal means perpendicular. So that means the angle in between is 90 degrees. Might as well save yourself the extra work. All right, so number 7, show that the vectors are orthogonal. So that's exactly what we were talking about. I think part of my image got cut off because I'm pretty sure this is supposed to be a negative 4j, and the other one is a negative 7i. That's what I'm going to go with. So negative 4j as a vector is going to be 0, negative 4. And negative 7i is going to be 7, 0. And if I want to show that the vectors are orthogonal, I'm going to take the dot product. So I'm going to do 0 times negative 7 plus negative 4 times 0, which gives me 0. And then show that the vectors are orthogonal. I'm going to say they are orthogonal, because the dot product is 0. Easy peasy. All right, number 8, show that the vectors are parallel and determine whether they have the same direction or opposite directions. So in order to determine that they are parallel, we need to find the angle in between those two vectors. So I'm going to go ahead and find the dot product. So I have 2/3 times 8 plus 1/2 times 6. So 2/3 times 8 plus 1/2 times 6 is 25/3. All right, and then from here, in order to find the angle in between, I needed two magnitudes. I'm going to call this A, and that's B. So magnitude of A is going to be the square root of 2/3 squared plus 1/2 squared. Let's see. So 2/3 squared plus 1/2 squared square root gives me 5/6. I'm using my calculator for all this, by the way. Don't be scared of the fractions, because you can use a calculator. It makes life a lot easier. Magnitude of b is going to be 8 squared plus 6 squared. Let's see. Oh, square root of 100. I feel like I should have known that, which gives me 10. Okay, now for the angle in between, I have cosine of theta equals my dot product divided by my two magnitudes. That should be 10, not 100. And then I'm going to take the inverse cosine of this and plug it into my calculator. Let's see what we get. Let's see, so inverse cosine of alpha y equals, to get my fraction bar, 25 over 3, and then 5/6 times 10 gives me 0 degrees. All right. So now that I know that the angle in between is 0 degrees, I can determine whether they are in the same direction or the opposite direction. Opposite direction vectors have an angle in between of 180 degrees. Same direction vectors have an angle in between of 0. So that means these two vectors are going in the same direction. And we know, whoa, that got weird, direction. And we know that the two vectors are parallel because the angle in between is 0 or 180, but in this case it's 0. All right, find the value of m so that the two vectors 5m plus 3j and 2i plus 7j are orthogonal. So since my vectors are orthogonal, that means the dot product has to equal 0. So I'm going to write these as vector form first, so 5m and 3. And I want to take the dot product with 2 and 7. So 5m times 2 is 10m plus 21. And since we know they're orthogonal, that means the dot product is 0. So subtract 21 from both sides, divide by 10, you get m equals 2.1. Negative 2.1. And that was the wrong color. There we go. All right, find the work done by a child pulling a sled through level snow by exerting a force of 20 pounds at an angle of 40 degrees with the horizontal for 200 feet. Okay, so this is very similar to this scenario. Let's go back with this kid. Except now we know that he is now traveling, 200 feet. So instead of redrawing this, I'm just going to do what I did here. So I found the horizontal and the vertical components of the force vector. So let's go back to the other problem. So 20 pounds at an angle of 40 degrees. So my force is going to be 20 cosine of 40 and 20 sine of 40, which I will go ahead and calculate, which we already did for the other problem. I should just copy that down. So that's 15.32 and 20 sine of 40, 12.86. So that's my force. And the other thing I need to know is the position. And my position vector basically comes from where this kid is traveling. So he's traveling horizontally for 200 feet. But is he traveling vertically at all? Nope, because we're assuming that he's pulling, oh, it says right here, level snow. Perfect. Okay, now when I want to find the amount of work, that is the dot product of your force vector and your position vector. So I am going to take 15.32 times 200 plus 12.86 times 0. So 15.32 times 200 is 3,064. And since my distance was in feet and my force was in pounds, my units is a foot-pound. we go. All right, so I think that takes care of vectors. Okay, so that was the vectors half of your chapter 6. This right here is now getting into trig form, but they are very, very, very closely related. They go back to direction and magnitude with vectors. You're just now looking at complex numbers in trig form. So instead of calling it direction and magnitude, we call it r and theta. But your process is still the same. So in order to write the complex number in trig form, we need to know two things. We need to know direction and magnitude, or r and theta. So r is the same thing as magnitude. So I'm going to take the square root of root 3 squared plus 1 squared, since there's a 1 in front of that I. That gives me square root of 4, which is 2. And then for theta, I'm going to graph it. So both of these components are positive, so that puts me in the first quadrant, where this is root 3 and this is 1. And then, of course, to find my angle, I'm going to use the inverse tangent. Opposite over adjacent, so 1 over root 3. Let's see, inverse tangent 1 over root 3 gives me 30 degrees. So my angle is 30 degrees, but if you look at the directions, it says your angle should be between 0 and 2 pi. So that means we need to convert this to radians. So 30 degrees in radians is pi over 6. Now, in order to write this in trig form, you are going to start with your r. So I'm going to have r CIS, which stands for cosine plus I sine of pi over 6. And there you go. Number 2, same thing. So I'm going to find r first, which is the square root of negative 2 squared plus negative 2 squared. That gives me 4 plus 4, which is 8, which is 2 root 2. And then I'm going to graph it. So negative 2 puts me in this quadrant. Inverse tangent. So inverse tangent of negative 2 over negative 2 gives you 45 degrees. Now we always want our angle in standard position, so that's going from my positive x-axis until I hit that complex number. So that in degrees is 225 degrees, or in radians is 5 pi over 4. Now I can write this in trig form, so I have 2 root 2 cosine I sine of 5 pi over 4. All right, let's keep going. So r square root 3 squared plus negative 3 root 3 squared. Please be careful when you're putting this in the calculator, because you do have those radicals. So make sure you are putting your numbers in parentheses. So negative 3 root 3 in parentheses and then square it. So my r ends up being 6. And then for my theta, I'm going to graph it. Let's see, positive and negative, that puts me over here. So this side is 3. This side is negative 3 root 3. Going to do inverse tangent again. So negative 3 root 3 over 3. That gives me, let's see, inverse tangent. Negative 3 root 3 over 3. Negative 60 degrees. But of course we want that in standard position. So that is going to be positive 300 degrees. And 300 degrees in radians is, let's see, 5 pi over 3. I took 300 and divided it by 180, by the way, if you're wondering where that 5 pi over 3 came from. Now to write this in trig form, I start with my r, cosine plus I sine, but I like to write the short way, of 5 pi over 3. All right. For number 14, it's just -5, so there's no I part. So that's like having -5 plus 0I. So when I graph it, that puts me right there on my negative x-axis. My r is just going to be 5 because this distance right here is just 5 units. And my theta is going to be 180 degrees, or pi. So now when I write this in trig form, I have 5 cosine plus I sine of pi. All right, now we want to go backwards. So instead of writing the trig form and instead of starting with the complex number and writing the trig form, we are now starting with the trig form and we want to write the complex number. So right here, I'm going to go ahead and start by distributing my 8, because usually when we have something in front of the parentheses, we distribute it. So I have 8 cosine of 7 pi over 4 plus 8I sine of 7 pi over 4. Now the trig pieces, the cosine of 7 pi over 4 and the sine of 7 pi over 4, I'm going to go ahead and put in my calculator. Since my angles are in radians, I am in the process of changing the mode to radians. And I'm going to do cosine of 7 pi over 4 gives me 0.707. Hopefully you recognize that decimal 0.707 as a radical, because that radical is root 2 over 2. And I always want your answers as radicals, not the decimals. And then sine of 7 pi over 4 is negative root 2 over 2, so negative 0.707. And then from here, I just need to simplify my expression. So that gives me 8 root 2 over 2. Well, 8 divided by 2 is 4, so that's 4 root 2, minus, since it was negative, 4I root 2. And there is your complex number. I'm going to do the same thing over here. I'm going to distribute. So I have 3 cosine of 3 pi over 2 plus 3I sine of 3 pi over 2. I'm going to do the trig pieces in my calculator. So cosine of 3 pi divided by 2 is 0. Sine of 3 pi divided by 2 is negative 1. So simplifying that expression, I have negative 3I. So there is my complex number. For number 17, we want to use trigonometric forms to find the product and the quotient of these two complex numbers. So for both of these, we want to find r and theta. So I'm going to call this r1. That's going to be the square root of negative 1 squared plus 1 squared. That gives me root 2. I'm going to do the same thing over here for r2. I'm sorry if you can hear Dexter screaming in the background. I think he's tired and cranky. Let's see, 1 plus 1 is 2, so square root of 2. Alright, now let's find theta. Oh, gotta graph it first. So negative 1, positive 1, that puts me over here. Negative 1, 1. Good old inverse tangent. That should give you negative 45 degrees. And of course we want our angle in standard position, so that is going to be 135 degrees. I'm going to leave these in degrees because the problem doesn't really specify, and we're using these angles to find other answers anyway. Do the same thing over here. So 1, 1. So 1, 1. Inverse tangent. You should end up with 45 degrees. All right. Now, let's go ahead and actually find the product and the quotient because I have all my pieces. So to find the product, z1 times z2, that is going to be r1 times r2 cosine I sine of theta 1 plus theta 2. So root 2 times root 2 is 2 cosine I sine of 180 degrees. And then from here I need to simplify it. So I can take cosine of 180, which is, oh darn, I'm in the wrong mode. Mode, degree. Okay, so cosine of 180, negative 1, plus I sine of 180. Sine of 180 is 0. So I can distribute that 2 in there. That gives me negative 2. So that right there is the product. Now we can find the quotient. So for the quotient, z1 divided by z2, that is going to be r1 over r2 cosine I sine of theta 1 minus theta 2. Oh, there we go. So that gives me root 2 over root 2 is just 1 cosine I sine of 90 degrees. And cosine of 90 degrees is 0. Sine of 90 degrees is 1. So my answer for this is just 1i, or just I if you don't feel like putting the 1 there. Oh, there's another one. I guess I'll do this one too. Let's go ahead and find the pieces. This stuff gets very repetitive. I don't know if you've noticed. So that's 25 plus 25, so the square root of 50, which is 5 root 2. And then for theta, I should probably graph it. Negative 5, 5 over here. Going to use inverse tangent, and theta will be negative 45 degrees, also known as 135 degrees in standard position. And then for this one, R2 is just going to be positive 3. You can go through that entire process of doing the square root of 0 squared plus negative 3 squared. That's just going to give you 3 in the end. Let's erase that. There we go. And then when I graph this, negative 3i, again that's 0 minus 3i. So when I graph that, that would put me down here on my negative y-axis. So theta 2 is going to be 270 degrees. Alright, now that we have the pieces, let's go ahead and start finding the product and the quotient. So z1 times z2 is going to be r1 times r2, so 5 root 2 times 3 cosine I sine of theta 1 plus theta 2. Let's see, so that's 15 root 2 cosine I sine of, let's see, 135, oh, that was weird, my calculator died. 135 minus 270 is negative 135. And then I am going to find cosine of negative 135 gives me negative root 2 over 2 plus I sine of negative 135, which is negative root 2 over 2. So I can change that to minus root 2 over 2. And then from here I am going to distribute. So that gives me 15 root 4, negative 15 root 4 over 2, minus 15 root 4 over 2i. And then from here, square root of 4 is just 2, so that means these are going to cancel and these are going to cancel. So that leaves me with negative 15 minus 15i. Alright, now for the quotient, z1 divided by z2, that gives me, let's see, r1 is 5 root 2, r2 is 3, cosine I sine of theta 1. Darn it! Oh, I did the product wrong. This should be plus. Man. Okay, so this should be plus. Ah, shoot. Okay, let's fix this. Ah, crap. I'm sorry. That's 405. I wonder how many of you were watching this and were like, oh, she's doing it wrong. Mrs. Oldham's doing it wrong. There we go. All right, let's see what this changes. So cosine of 405 is positive root 2 over 2. Sine of 405 is positive root 2 over 2. Whoops. So let me just get rid of this negative. Change this to a plus and this to a plus. Get rid of this negative. There we go. All right, problem solved. So continuing with the quotient, now I actually subtract my angles. So 135 minus 270. Ay, ay, ay. So let's see. So 5 root 2 over 3 cosine I sine of negative 135. Oh boy, ran out of space. Let's put that over here. Okay, so I have 5 root 2 over 3 times negative root 2 over 2 minus root 2 over 2i, because we already evaluated that the first time. So that gives me, let's see, negative 5 root 4 over 6. I don't know why I'm writing so big. I'm going to run out of space. So negative 5 root 4 over 6 minus 5 root 4 over 6. So let's see. 4 is 2. So that gives me negative 10 sixths minus 10 sixths I, also known as negative 5 thirds minus 5 thirds I. All right, there is the quotient. Okay, de Moivre's theorem. So de Moivre's theorem allows us to take any complex number and raise it to a power. Because why wouldn't you want to do that? That's a very fun thing to do. But again, I'm going to find r and theta. Same thing as direction and magnitude. So r is the square root of 1 squared plus negative 3 squared, negative root 3 squared, which gives me 1 plus 3 square root of 4, which is 2. And then for theta, gonna graph it. So 1 negative root 3, inverse tangent, opposite over adjacent. Plug that in. That gives me negative 60 degrees. Let me actually plug that in. I did my hand trick, and I am not super confident in my hand trick skills right now, considering I just botched up that entire question. Yeah, it's negative 60. So theta in standard position is going to be 300 degrees. All right. So de Moivre's theorem, I need to know 3 things. I need to know r, which I have. I need to know theta, which I have, and I need to know n, which is right here. N is your exponent. So in order to calculate de Moivre's theorem, I'm going to take 2 and raise it to the nth power, cosine I sine of n times theta, and then I just need to simplify this expression. So 2 to the 5th is 32, cosine I sine of 1500 degrees. So I have 32 times cosine of 1500 is 1/2, and then plus I sine of 1500. So plus root 3 over 2i, and then I can distribute that 32. So 32 divided by 2 is 16. So that gives me 16 plus 16 root 3 I. Alright, last problem. I am going to do the same thing, so I'm going to find r. So r is the square root of negative root 3 over 2 squared plus negative 1/2 squared, which gives me, I am going to take a guess out there and say that this is 1. Let's see. But I'm also going to plug it into my calculator because I don't want to be wrong. Haha, it was 1. I knew that because that was an ordered pair from the unit circle. Alright, let's find the angle. So my angle is negative, negative, so that puts me over here. So negative root 3 over 2, negative 1/2. Inverse tangent. That gives me, I'm going to guess and say 210 degrees in the end. But let's see. So inverse tangent of negative 0.5, negative 1/2 over negative root 3 over 2. Be careful when you're plugging this into the calculator. That gives me 30 degrees, which in standard position is 210 degrees, which I think is what I said. So for Dimloff's theorem, we need r, theta, and n. R, theta, and n. And then we can just work through the theorem. So I have 1 to the 20th power. Whoops, what am I doing? Cosine I sine of n times theta. Well, 1 to the 20th power is just 1, of course. So that just becomes cosine I sine of 20 times 210, which is 4,200 degrees. So cosine of 4,200 degrees is negative 1/2 plus I sine of 4,200 degrees is, what did I just do? Got an error on my calculator. Oh, that's because I did inverse sine instead of regular sine. So sine of 4,200 degrees is negative 0.866, which hopefully you all know is negative root 3 over 2, and then I. And voila, there is your answer for number 20. Alright, so that concludes everything that you need to know for your Chapter 6 test. I hope the video helps you get prepared. Adios!